Uh, Welcome to my e-learning session. Recently we have covered, in the class we have covered 2D efficiency, and similar to that 2D efficiency we have another type of shape that is called as a 3D. So on this 3D we are going to look at what type of 3D shapes are more efficient. So in a way, the topic for today's lesson is 3D efficiency. Now 3D shapes, like 3D shapes, namely like a cube, cylinder, rectangular prism. So this type of like shapes, they are called as 3D shapes. So from those 3D shapes we are going to see which one is most efficient. To recollect back, like in a 2D efficiency, we have learned that circle is the most efficient, isn't it? Is the most efficient. Why the circle is most efficient is because it has the more area and also it has the less perimeter. So you have to remember these 2 points. Based on this one, similar to this is a 2D shape, similar to this 2D shape circle, we have a 3D shape. So in 3D shape, similar to circle, is called as a sphere. So sphere is the most efficient 3D shape. Okay, most efficient 3D shape. So I have to rush the rush the lesson because I can't record a huge lesson, so that's why I have to rush it. Sphere is the most efficient. Now for this sphere, we can say that it has less total surface area, TSA, okay, and it has a more volume or more capacity. It has a more volume or capacity. So if the shape has more volume or capacity, which means if you can put more inside that container or whatever, so you can say that it is more efficient, obviously, isn't it? Or that container or that shape can hold more, that is called as a capacity. So this type of shape will be the most efficient. And total surface area, the sphere, this spheres total surface area, just the surface area. So like its occupancy, if the occupancy is less than the shape is called said to be more efficient. Okay, so then in 2D shapes we have learned that more like a circle, even though if the shape is not a circle, but if it is like a circle, then we say that it is more efficient than the other shapes. So that's why we say that more the number of sides, more efficient is the 2D shape. And similar to that 2D shape, in 3D, especially the cube, with all the sides equal, so that means from this cube is also a rectangular prism. Okay, this is also a rectangular prism. But from any kind of rectangular prism, cube is the most efficient because the reason is all sides are equal and it is closer to the sphere. It is closer to the sphere in the sense like it somewhat look like a sphere. So that's why cube is the most efficient from any type of rectangular prism. Then coming to this another type of 3D shape, that is a cylinder. Okay, cylinder. For the cylinder will be of variety, like it will be of different shapes, different size, isn't it? So this mug just now, if you see this cup, so this cup actually it is long, isn't it? quite long, and its diameter from the down, its diameter, I guess it is shorter than the height of a cylinder. So now cylinder, if we compare it, then it is said that if the height, H-E-I-G-H-T, height and the diameter, if the height and the diameter are equal, the shape is most efficient. Okay, the shape is most, I'm just putting a star mark. Cylinder with the equal height and diameter, like as I showed, like if the height of a cylinder and the diameter is this one, diameter of the shape is equal, then the cylinder is said to be most efficient. Okay, cylinder. Then so with this concepts, short concepts, for more details you can go through the textbook. With the with this concept, let's calculate something else. We'll try to calculate. All right, this container, suppose this cylinder, okay, this cup, what type of cylinder will be most efficient, and its capacity is given as 480 ml. Its capacity is this much, and you are asked to find the dimension. You are asked to find the most efficient dimension. You are asked to find the most efficient dimension. So for this container with this capacity, the most efficient dimension, how you have to find is, you have to find through the formula of volume of a cylinder. The volume of a cylinder is given by pi r square h. Okay, volume of a cylinder is given by pi r square h. Then in an earlier concept, we have learnt that a cylinder with equal height and the diameter is said to be most efficient. Then here you can consider that h is equal to diameter. Okay, h is equal to d. But here in the formula you can see d is not used, but r is used. Therefore you can say that h is equal to 2r. Why 2r? Because diameter is equal to 2r, because d is equal to 2r, isn't it? Diameter is equal to 2r. Therefore h can be written as 2r. Therefore you can replace this h by 2r. When you replace it, it will be equal to pi r square times h. Now it has become 2r. Now here I forgot one thing. Here the capacity is given by the condition, mathematical condition. We know that 1 centimeter cube in volume is equal to 1 milliliter in capacity. Therefore 480 centimeter cube will be equal to 480 ml. Okay, just now 480 ml is given, so therefore it will be equal to 480 centimeter cube. You can put, instead of this volume, you can put this value. You can put it as 480 is equal to pi r square times 2r. Now solve it. 480 is equal to, pi is given by a value 3.14 times 2 times r cube. Why r cube? R square times r is r cube. Okay, so it will be 480 is equal to 248 to 12236. It will be 6.28 r cube. Then it will be equal to r cube is equal to 480 divided by 6.28. Okay, then you can divide this one and find cube root of r cube is equal to cube root of this value of this value. Okay, you divide it and get the value, you find this, then cube and the cube root will be cancelled, so r will be equal to cube root of this value. So you punch in the calculate, cube root of this one will be equal to something centimeter. Understood? Therefore you are getting the value of radius, but in here the dimension should be diameter and the height. Okay, dimension should be diameter and the height, this height. So you can conclude that r, so d is equal to 2r, therefore diameter will be equal to 2 times this r. Okay, 2 times this r, it will be equal to this much, therefore d will be equal to h. D will be equal to h. Then finally you can conclude that with this much d is equal to h is equal to this much value, you can say that with this dimension the 3D cylinder is most efficient. You can conclude like this. So with this is a use of 3D efficiency, and you can use this type of method. You are analyzing power in many problems we have in the back exercise. You can go through that back exercise and let me know which questions you are not able to solve it. Okay, so probably I would like to give you question number 4 and question number 6 as an activity. Okay, for just now you try to solve these 2 questions and let me know if you can solve it or not. If any further doubt is there, please comment below in the activity. Thank you so much.